Hello students, welcome to the physics lesson. Today, we will discuss your mid-exam. Since we cannot do it in the classroom, I will give you the discussion in the form of videos. Now, let's begin from number 1. A spring is hung from a beam and a load is suspended from it. Figure 1.1 shows the spring before and after suspending the load. 1a, using the letters on figure 1.1, state which distance you would need to measure in order to find the extension of the spring. Extension means the difference in length. In the figure, we can see that the initial length of the spring is y. After the load is added, the length of the spring becomes z. So, the extension of the spring is the distance between y, z, or zy. That's the answer for question 1a. Distance yz or zy. Question 1b. An experimenter measures the extension of the spring with different loads and obtains the graph shown in figure 1.2. Question 1bi. When the experimenter hangs an unknown load on the spring, the extension of the spring is 1.7 cm. Use figure 1.2 to find the weight of the unknown load. Show clearly on the graph how you obtain the value. Let's look at figure 1.2. To find the unknown load, first we have to locate the position of 1.7 cm extension on the graph. Now let's count from 1. 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, and then 1.7. So this is the location of the 1.7 centimeter. Now, draw a horizontal line from the position of 1.7 centimeter extension until the line touches the line of the graph. We will get this line. After that, draw a vertical line from the point where the line of the graph and our horizontal line meets, downwards until it touches the x-axis. This is the line. The point where the vertical line meets the x-axis is the value of the load. Let's count from 4, 4.1, 4.2. So 4.2 is the point where the vertical line meets the x-axis. This means that 4.2 is the value of the load. Now we can answer question 1bi. Question 1bi, weight equals to 4.2 Newton. Question 1bi. State the value of the tension in the spring when this load is hanging from it. After the load is hung on the spring does not move. Please recall your memory about Newton's first law of motion. If a body does not move, then the resultant force on the body equals to 0. If the resultant force on the spring equals to 0, then the value of the tension equals to the value of the load. Once again, if the resultant force on the spring equals to 0, then the value of the tension equals to the value of the load. Why? Because the direction of the tension is upwards, while the direction of the load is downwards. This means that tension and load have opposite direction. Therefore, they will have the same value, so that the resultant can be equal to 0. Remember, the resultant of two opposite forces is the subtraction of their magnitudes or values. So, to answer this question, tension equals to the weight or the load, which is 4.2 Newton. Question 1b III. The load is pulled down further. State what happens to the tension in the spring. When the load is pulled down, the tension increases because it has to follow the rule that the resultant force equals to 0 when the body does not move. So that's the answer for question 1b III. The tension increases. Question 1b IV. After being pulled down, the load is released. State what happens to the load immediately after it is released. After the load is released, the downwards force will immediately decrease. Then the tension will be greater than the load. Remember, the direction of the tension is upwards. So, the tension will pull the load upwards. The answer can be the load is pulled up by the tension of the spring, or the load goes up, or the load moves upwards.